Okay, how do we find an inverse function? First, ladies and gentlemen, I'll show you the visual way of pictorially doing it, and then I'll show you the algebraic way of systematically finding the equation. Alright? So, first of all, graphically, that's visually by eye. There are three ways of doing it, and each of them is pretty exciting, but I'll show you each in turn. First of all, we're looking to do the inverse of y equals 2x, and we're going to do the old swap x and y and then rotate and flip technique, as I call it, and you'll understand why in a moment. So we've just swapped x and y, and that at which you are looking is the inverse. All we've got to do now is reorientate that graph so that the positive y is pointing upwards and the positive x is pointing to the right. So we first of all have to do a rotation of 90 degrees in the anti-clockwise direction, which I'll show you now. Look at that. See? You get it? Alright, now the only problem with this is that the positive x is now pointing to the left, which of course is not what we want. The y is okay, but the x isn't. So now we're going to flip that on the y-axis, actually reflected in the y-axis in fact, and then we will get what we want. Yes, what does that say? Reflect the resulting graph. Yes, okay, around the y-axis. So that the x now points to the right as it's supposed to do, and there it is, yeah? Now, I think it's pretty clear that where we started with what was the graph of y is 2x looks very much like the graph of y equals half x. That's pretty neat, isn't it? So that's the first way to do it, yeah? So, we've transformed that into the y equals half x. Second way, now, we reflect the original function directly about the line y equals x. That's the way that everybody's been told about. But sometimes that's a little bit hard to do depending on how complicated the original graph is. But it's one of your options. The third one, which I think is the most exciting and devious way of doing it, particularly if you're in an exam, and they can't stop you doing this in an exam, it's perfectly legal. You take a piece of paper, you sketch the original function in the lower right-hand corner, like that. That looks like x squared to me, the right-hand half of it. Then you make a fold, a 45-degree fold, and then you basically fold the paper upwards and look through to the other side to see the shape of the inverse. This is like that. There's your fold, right? And then you basically do this. Ah, there's the inverse. That's pretty cool, isn't it? It's very, very cool. It's so cool, I think I need to go back and show you again. Okay, there's the original, and abracadabra, look at that. Isn't that beautiful? You see, you're looking through the paper to see the inverse, but you see it nonetheless, yeah? Moving right along, now we're going to do the maths part of it, okay? Algebraically. And there are two ways of doing it algebraically. So, there are two components to specifying an inverse function, that is the rule and the domain. If you are asked for the inverse function, ladies and gentlemen, you need to specify both the rule and the domain. However, and it's a big however, if they just ask you for the rule, that is just the equation. You do not give them the domain. And the reason for that is basically if you give them the domain and you get it wrong, then they will take marks off you anyway. Okay, so you never give them any more than they ask for. That's the golden rule of maths. Okay, as I said, there are two methods available for finding the inverse. There's the swap x and y and solve method, and there's the solve the spooky conundrum method, yeah? That thing there. I'll show you both. They're both fascinating, but you have to be careful how you do them. Alright, this one, we've got find the inverse function of g of x is 1 over 9 minus x, where x is greater than 9, okay? And we're going to do the swap x and y and solve, alright? So we've got g of x equals this beastie here, and let's go with that. We do need the range of g of x before we do the swapping, because this is going to be the domain of the inverse, and because they asked us for the inverse function, not just the rule, we have to supply the domain, yeah? So, we just get a little visual on the graph. that looks like what we're looking for. That's an upside down right hand side sort of thing of a rectangular hyperbola. Looks like it goes from minus infinity to 0, okay, not including the 0. So that's our range of original, so that's the domain of our inverse, yeah? Good. Now, NB, yes, this is a very big NB. You need to be careful with your setting out and your notation with this swapping X and Y caper. You can say some outlandishly ridiculous things if you don't notate what you're doing. Yeah, document what you're doing. Please, please document what you're doing. Express the inverse function back in its original notation. So if they say the original is g of x, then for heaven's sake, specify the inverse as g to the minus 1 of x, not y, and not anything else either, okay? Now, I always start off, and I advise you to do the same, by letting y equal the rule, okay, of the original, not g of x, because I want to swap x and y, not x and g. It's too much trouble swapping x and g, and you can get yourself into a quagmire. So I start off by just saying that, okay? And at the end, I revert back to the g notation where I need to, okay? But for the swapping, I just do it cleanly like this. So for the inverse, swap x and y, and I get that, and then I'm solving it for y, okay? There it is. Now I've got it. Now I'm just going to revert back into the g notation. Remembering to do that, there's my equation and there's my domain. So that's it. That's it. But please be careful and please put this line in here. For the inverse, swap x and y, or just for the inverse, x equals this, or something so that they know what you're doing. Not just y equals minus 1 over x minus 9, and then x equals minus 1 over y minus 9 without even saying what you're doing, because that's just mathematical craziness, yeah? Okay, there's the graph of the inverse in all its glory for you, all right? We weren't asked to do that, but I just thought I'd throw it in for good measure. Now, here's the same equation solved with the marvellous thingy equation method, okay? We find the range of g of x just as we did before. It's going to be the domain of the inverse, so I won't repeat that process. And have a look at this now. This is our marvellous little equation, okay? I'm going to solve it for g to the minus 1 of x, okay, within that equation. So here we go. Now, g of g to the minus 1 of x is 1 over 9 minus not x, but g to the minus 1 of x, isn't it, right? See, look at that. See, so g of something else is 1 over 9 minus the something else, and something else in this case being g to the minus 1 of x, yeah? Now, we know that that equals x, and therefore all we have to do now is just to solve that for g to the minus 1 of x. It's very simple. There you go, look. And it's just a simple matter now to solve it for g to the minus 1 of x, as before. Now that's very cool, you've got to agree, yeah? Alright, another one. In this case we have to find the rule. Did you hear that word? The rule of the inverse function of h of x equals x squared, where x goes from 0 including 0 up to infinity. Now, in this case we do not specify the domain. No, we do not. So yes, just the rule. No need for the domain. So I'm using my marvellous new method here. So I'm saying h of h to the minus 1 of x is equal to x. And we know therefore, because h is x squared, we know that therefore we have h to the minus 1x all squared is going to be equal to x. Yeah? Have a look at that. Do you agree? Yeah, it's fine, and therefore h to the minus 1 of x is just x to the half. Well, that was nice and simple, wasn't it? It was beautiful. See, this is a good method of doing it if you get used to doing it, yeah? Now, we're doing some CAS now, apparently. Find the rule of the inverse of y equals 3 root x plus 2 plus 4, and sketch the graph of both functions. So, on CAS, we can solve for the inverse by swapping x and y and then solving for y. It's pretty cool how you do it, so I'll show you in a moment. Then we sketch both graphs, yeah? So NB, the inverse will be, in this case, a restricted function. So we need to specify this in the CAS handheld for the graph entry screen, all right? So what have we got here? We've got y equals 3 times root x plus 2 plus 4, and we know that the range of this, if we figure it out, is going to be from 4, including the 4 up to infinity. Okay, it's a square rooty thing, okay, which has been shifted up by 4 and over to the left by 2 for that matter, and there's a dilation factor in there thrown in as well. But never mind about all that. So hence the domain of the inverse is going to be from 4 to infinity, including the 4. Okay, so we're going to go over the screen now, and we're going to show you some tricks on the CAS. So what have I got here, ladies and gentlemen? Well, I've got here, I'm saying 3 root of x plus 2 add 4. I'm saving that to f1 of x. Yeah. Now this is the very important line here. On the TI CAS handheld, you say solve for f1 of not x but y equals x, and you solve it for y. Okay, so you are in effect swapping x and y. It is very, very cool. And you get this, okay? The calculator spat that out. That is the inverse function. Shock horror? Yes, that's right. And so what I'm going to do now is I'm going to save that as a different function, okay? So I'm just plonking it straight in, and I'm putting this little given that x is greater than or equal to 4, and I'm then defining that as f2 of x, yeah? Oh, that's the original, and that's the inverse, in case you hadn't picked that up, which I think you probably did. And here are the graphs. Aren't they amazing? Aren't they beautiful? So we've got the original in here, the square rooty thing, and we've got the inverse here, the quadratic-y thing. Isn't that marvellous? So we'll leave it at that, and we'll see you soon. All the best.